This is Calculus 2 class. We start Module 4. We change the concept from integration power series to the parametric equation. I want to ask one question. Have you ever watched object move around the space? Like car around the stack, a Paris wheel spinning, person walking along the curved path. It is very describe the motion using only y equal f of x. We're gonna introduce new way to represent those kind of curve with parametric equation. So I'm gonna start with a very simple example before introduce definition of parametric equation. This is a circle I sketch here. The first one is a circle, second is a circle, third is a circle. What is different of three circles, three graphs? Everyone notice? The first one is just circle. Second is they give the arrow. Arrow is moving here, going to this direction. They give the direction, right? Same circle, shape is just circle, curve is just circle, but this direction is the arrow gonna be clockwise. This one, first one, doesn't give any information of object movement, just we sketch the equation of a circle, that's the circle equation, we sketch it. Second is movement of object is counterclockwise, they move that way. Third one is object moved clockwise. This is counterclockwise. This one is clockwise. How we can represent three different curves with direction? That's we're gonna study parametric equation. This is definition of parametric equation and parametric curve. F is, let's introduce third parameter, third variable is t right there, t. We're gonna using t. Usually t represents time. We call this variable is parameter. They decide the position of x, position of y over a and b. T gonna move a and b. Then we have this two equation. X is depends on time. Y is depends on time. Then you have two equation that we call parametric equation. Parameter is time t. So we're gonna up the equation. We have parametric curve t equal a. Then we have f of a. T equal a, g of a. That's the we call initial point. T equal b. Plug in the here, f of b, t equal b, g of b, that's the y value, that's the terminal point. That's the definition of parametric equation. Where you're gonna using it, this approach is usually describing motion and curves in space or complex shape, which is very difficult to represent with y equal f. When you give the parametric equation right here, guys, look at the x is t squared minus 2t, y equal t plus 1. Both depends on parameter t. That's the parameter. This is t equals 0 is a starting point. T equals 4 is initial point, initial ending point. So first question is 1 and 1. That's represent x value. This represents y value. So when you give the parametric equation, we can sketch the parametric curve based on the parametric equation. First question is x equal 1, y equal on the curve. So let's check it. So x equal 1. So x defined parametric is t squared minus 2t. So right here, So I'm gonna plug in here 1 equal t squared minus 2t, right? Y equal 1, y equal 1, which meaning is 1 equal t plus 1. So second equation, you can find the t value, t equals 0. So t equals 0 is y value is 1. Let's plug in the t equals 0 is this value. 1 equal 0 minus 0. That's true and false. That's the false. So 1 and 1, position 1 and 1 should not be on the parametric curve. So this is not on the graph. Okay? So that's we're gonna evaluate the parametric equation given time. Where is the position gonna be? That's represent parametric equation. Now we're gonna just try to sketch the curve defined by the parametric equation. How we gonna sketch it? So here is x, here is y, parameter is t value. T is gonna be 0 and 4. I just put any number between 0 and 4, t equals 0, x value gonna be 0. Y value gonna be t equals 0, y value gonna be 1. T equals 1, x value gonna be 1 minus 2, that's the negative 1. Y value gonna be, that's gonna be 2. T equal 2, x gonna be 4 minus 4, that's the 0. Y gonna be 3. 3, x gonna be 9 minus 6, 3. Y equal 4. T equal 4, x gonna be 16 minus 8, 8. Y value is 5. So you find the x value, y value. That's represent position. So we're gonna say here, t equals 0, position gonna be 0 and 1. T equal 1, position gonna be negative 1 and 2. T equal 2, 0 and 3. T equal 3, 3 and 4. T equal 4, 8 and 5. That's how to move the objective. T equals 0 to 4, how object to move on the coordinate plane. Let's plot it, guys. So t equals 0, 0 and 1. 0 and 1 is right here. So that is t equals 0. T equals 1 is negative 1 and 2. Negative 1 and 2 is right there. That's t equals 1. T equals 2, 0 and 3 right here. T equals 3. This point. T equals 3, 3 and 4. 3 and 4 is right there. T equals 4. T equals 4, 5, 8 or 5. 5 is right there. T equals 5. So they move this direction here, 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 here. So you have the direction of this object. Start point right here. That's the initial point. Move to this direction, this object, and this one. The regular form of function very hard to represent direction. They cannot represent direction of object. So that's what we're gonna use parametric equation, show the movement of object. So now we learn definition of parameter. So we want to know what parametric equation represent is the Gaussian equation. Gaussian equation meaning is that's gonna be, guys, that's gonna be a form of y equal f of x form. That's the Gaussian equation. So we wanna find Gaussian equation when they give parametric equation. The method is eliminating parameter. Parameter is a third variable. So we're gonna eliminate the third variable to the find Gaussian equation. So here's a step. So we have parametric equation, then solve for the T1 equation. You have two equations. Usually you have two parametric equations. You're gonna use one of them to solve for t, then you're going to substitute into the equation we didn't use. Then we're going to have a rectangular equation. That's we're going to find rectangular equation or Gaussian equation. Here is example about eliminating parameters. So here's I give parameter equation we sketched the previous example. X equal t square minus 2t, y equal t plus 1. Third parameter is t. So what do you have to do? Solve for t, one of them. First one, this is 1, this is 2. So which one you're gonna solve for t? Which one looks like easier? Here is the t is, guys, t is square. Here's degree 1 is t is 1. So I'm gonna use the second one. So y equal t plus 1, solve for t. So t gonna be y minus 1. Then what you have to do, this t value go to equation 1. So you're gonna plug in this one, equation 1. X equal y minus 1 square minus 2y minus 1. So then t will be gone. Now what do you have? Only x and y, right? So that's we call this one is Gaussian equation or rectangular equation. Okay, parameter is gone. Now let's expand this one. X equal y minus 1, y minus 1 minus 2y minus 1. This one is y square, y minus y plus 1 minus 2y plus 2. Now y square, this one, this one, this one together, 4y plus 3. So that's represent here x equal y square minus 4y plus 3 is rectangular equation. This one is parametric equation. Everyone clear about that? Let's have more example. Here is I give parametric equation. We have Gaussian equation or rectangular equation. Sketch this parametric equation. First, we're going to sketch first, guys. How gonna sketch this parametric equation? T, x gonna be cosine theta, y is sine theta, t gonna be start 0 and 2 pi. So let's fill out this table. So t equals 0, cosine 0 is, guys, everyone, 1. Sine 0 is 0. So you have position of this one is 1 and 0. Now, pi over 2, cosine pi over 2 is 0, sine pi over 2 is 1. That position gonna be 0 and 1. Pi, t equal pi, cosine is gonna be negative 1. Sine pi is 0, position gonna be negative 1 and 0. 3 pi over 2, position gonna be cosine 3 pi over 2 is 0. Cosine 3 pi, sine 3 pi 2 is negative 1. So position gonna be 0 and negative 1. 2 pi, the same thing is 0. That's gonna be 1 and 0. Time is move, stop point is 0, end point 2 pi. Moving this direction, guys, remember that. So I'm gonna plot this point right here. 1 and 0 is here. That's gonna be t equals 0. 0 and 1 is right here. That's gonna be t equal pi over 2. I'm very careful. So this one is, I'm going stop point here, going to this direction, going to this direction, okay? T equals pi gonna be t equal pi, that gives position is negative 1 and 0, so that's going to this direction. Guys, make sense? 3 pi over 2, t equals 3 pi over 2. Position is 0 and negative 1. Here it is right here. 0 and negative 1, t equals 3 pi over 2. This direction. T equal 2 pi is 1 and 0, right? So go back to here. So you're gonna sketch the right here. That's the parametric equation for this. That's the curve for parametric equation. So you see the direction. This is initial point, going to the counterclockwise, come back where they stopped. Now, let's change this one is Gaussian equation, rectangular equation. We're gonna eliminate, guys, what the key point is eliminate parameter t. How can you eliminate t? Cosine sine, you can use Pythagorean identity. What do you know about Pythagorean identities? Cosine square t plus sine square t gonna be 1. So what is the cosine theta here? Cosine theta is x. So that's the x square plus sine theta is y square equal 1. So Gaussian equation is the circle equation. See? Let's practice another example, guys. This time x equals sine t, y equals cosine t between the 0 and 2 pi. So let's do here, t equals 0, sine t is 0, cosine t gonna be 1. So let's just sketch 0 and 1. Its start point is right here. That's gonna be t equals 0. Pi over 2, sine pi over 2 is 1, cosine pi over 2 0. 1 and 0, that position gonna be right here. That's gonna be t equal pi over 2. So going to this direction, right? Pi, sine pi gonna be 0. Cosine pi gonna be -1. So t equal pi, position gonna be 0 and -1. That position gonna be t equal pi. So you move to that direction. Now, t equals 3 pi over 2, sine 3 pi over 2 is -1. Cosine 3 pi over 2 gonna be 0. So that's gonna be 0 and -1 is right here. -1 and 0 is right there. That's t gonna be 3 pi over 2. Move to that direction. Last one. T equal 2 pi. Sine is gonna be 0. Cosine is 1. That's gonna be here, right there. T equal 2 pi. So you're gonna go to this direction. So what do you notice the graph, guys? This is also a circle. What is the difference from previous one? This is clockwise direction. So parametric equation, two different parametric equation represent two different curve. One is counterclockwise, the other is clockwise. So clearly they give the direction of movement. So let's find rectangular equation here, guys. Same thing, we can use cosine square t plus sine square t gonna be 1. This time, cosine t is y value, y square. Sine t gonna be x square equal 1. So parametric equation represent different curve with direction, but here is rectangular equation represent the same. Let's do one more example, guys. Here is gonna be sketch the curve with the parametric equation x equals sine t, y equals sine square t. So this one is the same thing. Here is a t equals 0, x equals sine t gonna be 0. Y equals sine square t also 0. T equal pi over 2, that's gonna be sine pi over 2 is 1. Sine square t is 1. T equal pi, sine pi over 0, y sine square t gonna be 0. T equals 3 pi over 2, sine is -1 here, -1 square is 1, 2 pi gonna be 0, here is a 0. But there is no interval, guys, but sine graph is a periodic function. So after 0 and 2 pi, they're gonna have the same value. So I'm gonna sketch 0 and 2 pi first, right here. 0 and 0 is right here. 2 pi gonna be 1 and 1 right there. So they move this direction first. So then what happened? Pi is 0 and 0. So t equals 0 is right here. T equal pi over 2 is right there. Then t equal pi is come back here, guys. Come back is this direction. Go to this one. First, they going to this direction. Second is going back to this direction. Then here is a t equal pi again. 3 pi over 2, negative 1 and 1. Negative 1 and 1 is right there. So go to this direction. So here is a t equal 3 pi over 2. Then what happened? T equal 2 pi. Another one, they going back here. This one is right here. Then it is going to be t equal 2 pi. So this one is go to the right, go to origin, go to the left, go back. That curve represents this parametric equation, okay? So how can find Gaussian equation? That's very simple, right? X equals sine t, y equals sine square t. So here is y equals sine square t, which meaning is sine t gonna be x. So sine gonna be replaced with x. This one is x squared. So Gaussian equation gonna be y equal x squared. But what happened here? X is not only a number, so you have to x. X is sine t. Sine t is always have a maximum minimum. X gonna be, maximum is gonna be 1, minimum is negative 1. That's you write down the Gaussian equation for this parametric equation. We discussed about parametric equation and sketch the parametric equation curve. So parametric equation represent movement of object. So this one is we study previous example. So right here, they start here. They're gonna move on this curve and the point right there. So we wanna know how far they travel. This object start here and there. How far they travel. Another way, what is the length of this part of curve? So that's our attention to the next couple of slides, guys. So calculus 1 class, so we studied object move here. Start point here, go to this one, move back, and go to this, move back, and move to this one. Because the object move the one dimension, that's very easy to find the distance, travel distance. But this one, they move Gaussian coordinate. So we have to want to know this length of curve. That's I'm gonna introduce distance formula for the parametric equation. So calculus 1 class, we use the position function is 1. But in the plane, position function has 2 coordinates. So what do you have here? X, Y. So X, Y is position on the plane, Gaussian coordinate. So when you give the t values A and B, that's represent position of object at time t. Now, how can they find velocity in the Gaussian coordinate? We have two velocity. One is horizontal velocity, that's the derivative of x, that's f prime. Vertical velocity, dy, that's the g prime t. That's represent velocity of object at each point. So this one is tells us how fast object move in x direction, y direction at this moment. Now, we want to calculate how far they travel. So now we need the speed, total rate of change of position. Speed gonna be calculated square root f prime, f prime t squared plus g prime t squared. That's gonna be speed at the time t. So what is total distance? Distance gonna be speed times period of time. That's we use integral a and b, and here is function gonna be speed. Then we can find the total distance object travel between the A and B. Also, this total distance object travel, another way you're gonna say, that's gonna be length of curve traced by parametric equation. So we're gonna practice finding total distance by using the example. Here is a parametric equation, and they give the time. I want to find arc length of curve. Another way, total distance they travel between the 0 and 2. So what you have to do first, you guys find the speed. Before we find the speed, we have to find the velocity of each component. So x prime t, that's going to be 3 minus 3t squared. Y prime t, 6t. This is a horizontal velocity, vertical velocity. Now we need to find the speed. That's going to be square root 3 minus 3t square, 6t square. Let's just simplify this square and square. So this part is going to be, this one is first, this one is 36t square. This one is 3 minus 3t square, 9 minus 18t square plus 9t fourth power. So we have this one is a square root 9 minus 18t square plus 9t fourth power plus 36t square. So let's simplify this one is, this one is 9t4. Then second part is gonna be negative 18t squared, 36t squared. That's gonna be 18t squared plus 9. So can you factor this one? When you factor it, you have this one is 3t squared plus 3 squared and square root. That's gonna be 3t squared plus 3. That's the speed of this parametric equation. Now, let's find the distance, the object travel or length of arc. That's gonna be integral 0 into 3t squared plus 3 dt. So this one is antiderivative 3t squared. That's gonna be t cubed plus 3t 0 and 2. This is gonna be 8 plus 6. That's gonna be 14. That's we're gonna calculate of this one, guys. Understand that? Let's do another example. Find the arc length of a curve given x t gonna be cosine t, y t gonna be sine t 0 and 2 pi. Previous example, that's represent a circle. You understand? Circumference circle, that's gonna be 2 pi r. So let's find arc length of curve of this circle when you give the parametric equation. So first step is gonna be find the derivative x prime t gonna be negative sine t, y prime t gonna be cosine t. So find the speed gonna be square root square of negative sine t square plus cosine t square. Negative sine t gonna be sine square t plus cosine square t. Pythagorean identity represents square root 1. That's gonna be 1. So you can find the arc of length integral where to where, 0 into pi, speed gonna be 1 dt. So what is antiderivative 1? That's the t where to where, 0 into pi, that's gonna be 2 pi. They confirm the circumference of circle with radius 1.